Yes. Professor Mukunda, in the closing part of his lecture, emphasized the use and the power of symmetry in understanding laws of physics. Here, Lorentz invariance or Lorentz covariance, where we have been talking about, is a part of what he has said. I would like to actually proceed a little further and take an explicit example of how this law is a very powerful, this method of doing things is very powerful. Let me go to the operation of the one particular one he was talking was about parity. And let me talk about parity in classical mechanics. Here, the operation of parity consists of replacing R by minus R. So, my velocity will get replaced by minus v. Acceleration, why is that? Because this is dr dt. And under parity, time is not being transformed. dr dt is getting transformed. Acceleration is d squared r dt squared, which is acceleration. And how is this transformed? This should transform as minus a. So, how should force transform? Force is, according to Newton's law, it is so it should transform as minus. Okay. Now let's look at gravitation, law of gravitation. What is law of gravitation? It is force is minus g mm by r cube r vector. Notice the left hand side changes to minus f to minus f. The right hand side also changes. So this law remains the same under a parity transformation. This law also remains the same under a rotation. Why? Because suppose I rotate my vector f and I rotate my vector r. If it is valid, if I can think of it as a passive transformation or as an active transformation, it doesn't matter. If my vector f rotates, r also rotates the same way. So notice that happens because left hand side is a vector and the right hand side is a vector. Otherwise this will not happen. One way of saying this, that this turns out to be the three-dimensional representation of the SO3 group that he was talking about. So R, X, Y, Z gives you a representation of SO3 is the rotation group. So under and F is Fx, Fy, Fz gives you, it doesn't matter, it's only whether I use X, Y, Z or the other one. If I apply an SO3 transformation, if I multiply by a group element of SO3, a representation of the group element of SO3 on this vector space, the left hand side and the right hand side will be the same. It's actually the same statement, physical statement, that I am rotating my coordinates or I am rotating all these vectors. Now, that's associated with rotation. What of course concerns us is the Lorentz transformation, the SO31 transformation which he was talking about. So, when I write down my equation, ultimately when I make a Lorentz transformation, it should be the same. Here, how could I say it is the same? Because the left hand side was a vector and the right hand side was a vector. There, I am going to say the left hand side is a 4 vector and the right hand side is a 4 vector. So, 4 vectors under SO31 or under a Lorentz transformation will have the same transformation property for the left hand side and the right hand side. So, if it's valid for one set of things, when I make that transformation, it will also be valid automatically. I don't have to keep checking it again and again by doing a lot of algebra. Okay? That is the virtue of writing all these things in terms of 4 vectors. Are there more complicated objects than, let's talk in rotation first, than a vector? Yes. The one which he mentioned about quadrupole rule. instead of quadrupole moment, I can also have moment. What was quadrupole moment? Quadrupole moment was a second xi xj dq now. This is your quadrupole moment. Simple, but I had written down an expression for moment of inertia tensor, which is instead of charge density, it is the mass density, which will give you. So that transforms as a 5-dimensional representation of SO3. So if I write a moment of inertia tensor on one side and I write it equal to something, I better have a 5-dimensional transformation. Then left hand side and the right hand side will transform the same. This concept is called the concept of covariance. Okay. Now let us take an example in which covariance is actually violated. Let me do that, and this is the case which there's also how does electric field transform? I will not worry about the index R here. I will just write down the electric field as Q by R squared. This is a little R cube with 4 pi epsilon naught I am forgetting. So how is E going to transform under? It is going to be under parity. I am still talking about parity. Then what about magnetic field? How is magnetic field produced? Magnetic field is produced by currents. That's the way magnetic field is produced. So if I want to write down a corresponding formula for magnetic field, I will write down this as mu 0 by 4 pi I dl cross R by R. Right? All of you are familiar with this formula. So now, how is dB going to transform under R going to minus R? When I change R going to minus R, dl will also transform. Right? So my dB is going to transform as dB. Right? So how is B going to transform? B is going to transform. Notice this is slightly counterintuitive. Think of a magnetic field in this direction. Think of two things. Here is a charge. I have an electric field. Let's firstly finish with the electric field. Let me put a mirror here. One can show a mirror image is the same as parity transformation plus a rotation. Let me not worry. So if I put a charge here, the electric field is in this direction. How do you think it's going to look in the mirror? The charge is going to look this way, the electric field is going to look this way. Now, let me put a magnetic field this way. How do you think it's going to look in the mirror? No, it will look that way. Why? Because how was this magnetic field produced? It was produced by a current loop. So, if this is, you have to worry about the source. If the current loop is like this, how is the current loop going to look like there? It is going to look like there. So, the magnetic field is going to point in that direction. So, the transformation property of electric field and magnetic field under parity is opposite. In fact, the electric field transforms very much like the displacement vector, position vector. This is called a polar vector and this is called an axial vector. Okay. Now I am ready to go to the main statement. As in right, all of you are familiar with this law. In fact, when I am going to discuss relativity in a few minutes, I will be using this. So under parity, how is this going to transform? Minus F. Q of course remains the same and E goes to minus E. What about V? Velocity goes to minus E. And V? Plus V. So I am perfectly okay. No problem. Now I am going to ask you people a question. Can find a term here which will violate parity from the things I have on the blackboard. Nothing more is required than what I have said. Can you write a term on the right hand side of this equation which will violate parity? I'll wait for a pardon?
Displacement. Force into displacement.
Force into displacement. No, the right hand side better be a vector. If it is not a vector, then under rotation it will not work. So, not force into displacement. Right hand side should contain quantities like charge, electric field, magnetic field, velocity, acceleration, and so on. Okay, suppose I wrote a term plus lambda b. What lambda? No, this is not a scalar. Lambda is some constant like charge. B vector is there. Okay, so now under parity transformation, what will this go to? It will go to plus lambda b. But then I need a minus sign to get this right. So if I had a term like this, the force equation here and the force equation here are not the same. Why? What will this equation become? This equation will become under parity Q into E plus V cross B minus lambda B. Right? So this would violate parity, because if these two equations have to be the same, the only way they can be the same is lambda must be equal to 0. Okay. Now, what is the physical meaning that I will attribute to lambda? I have Q, the charge, electric charge coupling to electric field. So, what is the meaning I would like to give to lambda? Magnetic charge. So, if you find in nature magnetic charge, then you automatically violate parity. Okay. So, there was a very, very major attempt to locate at magnetic charges. In fact, that attempt is not ceased. It is still continuing in its own way, and the presence or absence of magnetic charge is crucial for electromagnetic theory to be invariant or not invariant under parity. Okay. I will not describe anything further. There are several experiments which have been carried. I will just mention one experiment which is sort of very interesting. Suppose there are magnetic charges or in nature, it is there. Then, if in cosmic rays, it may not be occurring here in cosmic, where do you think they will accumulate on the earth? Which place on the earth do you think they will accumulate? In the poles. Okay? So, the idea was it will accumulate on the poles. And the theorists had actually, this goes by the name of magnetic monopole. The theorists tried to evaluate the mass of these particles. It turned out to be very heavy, much heavier than proton mass. So they thought it's all going to sink somewhere in the pole and it will be inside the ice. So a team went, dug North Pole, and from North Pole they brought about a ton of ice. And they took the ton of ice and kept it on a very strong magnetic field. So if there is a magnetic monopole, it will get accelerated. If it will get accelerated, it will ionize the water atoms in ice, and that should leave a track, and we should see it. No such tracks were found. So these are the kind of experiments that have been attempted to look for magnetic monopoles. Till now, there is no evidence for magnetic monopole. So notice the power of the argument of symmetry. Symmetry tells me that this term should be absent, but nature may not obey the symmetry. So you have to go and check whether this is so or not. It also turns out, I will not have time to say, this symmetry violates time reversal. If you have a magnetic monopole, you get two things: one violation of parity, one violation of time reversal. So we can expect to get 2 Nobel Prizes if they are able to locate the magnetic. So now let me me get back to what I want to
From Maxwell's equation, del cross B is equal to 0.
Pardon?
Del cross B is 0.
Right.
That also we can say that there is a no magnetic monopole because
Yes,
it's
that's
closed.
correct. That's correct. Correct.
Magnetic lines are closed.
Absolutely. So now let me get the reason I wanted to say this. This is an example of power of symmetry argument. So now let me get back to where I was yesterday and we will continue. Right? I think now the point will be clear that I wrote down x nu, which I have written down as x0, x1, x2, x3, and my x0 was ct. Then my transformation, the kind of transformation I will stick to will be Lorentz transformation along the x-axis. Otherwise, it will become very complicated. I wrote down x prime nu was equal to lambda mu nu x nu, and lambda mu nu was matrix. I had gamma minus gamma beta 0 0 minus gamma beta. Anything that transforms like this is a 4 vector. Now, we also have the following thing, which was an invariant, which I will write it in the following form: x0 prime squared minus x1 squared, x1, x prime 1 squared, x prime 2 squared minus x prime 3 squared equal to x. Well, I will write it in terms of differential of it in the following form. I will take two events which are separated by, one is occurring at x0, x1, x2, x3, one event E1, and E2 is occurring at x0 plus dx0, x1 plus dx1, x2 plus dx2, x3. So, the interval between these two is dx0 squared, the quantity dx1 squared minus dx2 squared minus dx3 squared. This quantity is the same in both the frames. That's because right from here I realized dx prime mu is lambda mu nu dx nu. So the transformation property of this is the same as transformation property of dx. So if the original invariance which I had written down earlier is valid, this should also be same in all frames. So this is equal to dx prime 0 square minus dx prime 1 square minus dx prime 2 square dx. So this does not change. Now, suppose I have in a frame in which the event 2 occurs at the same spatial coordinate as event 1. That is, let me assume dx in S prime, let me assume dx prime 1 equal to dx prime 2. dx minus v. That is, the event occurs at the same spatial domain. Then, what will this be? This will be just dx prime 0 squared in the rest frame of the events that is taking place. This time, the rest frame is going to come out to be the same answer given by this in any frame. So this I will call it c squared d tau squared, and this time is given the name of proper time. D tau. So if I have a particle which is moving and with some velocity v changing, doesn't matter. So at a particular time t, I go to that frame in which the particle has velocity. In that frame, the proper change d tau is the proper time associated with t. And this value is independent of the choice of frame that I do. So this is a scalar quantity, Lorentz scale. So this doesn't change. Now, let me go back to what I want to do now. I will write down the 4 velocity.
So how do we understand d tau?
Pardon?
How do we understand d tau?
How do you understand d tau?
Proper time.
Proper time? Okay. You have to understand it as a clock attached to the particle which you are looking at. Say, if I am looking at a particle, right now I am going to go into that. So, in the frame in which, suppose I am attached to the particle, you mean the particle doesn't move, right? The clock is changing, and that will satisfy the condition dx prime u 1, dx prime 2, dx prime 3 equals 0. So the clock, the time that elapses in that clock is the proper time.
And that time for other frame of reference? Then?
No, that will not be the time for other frame of reference. For the other frame of reference, good. Now suppose that particle is moving with a velocity v in the other frame. So my dx1
Time dilation.
will be, dx1 will be vx or vx dt, dx2 will be vy dt, and dx3 will be vz dt. Right? Because in my frame, if that one is at rest, and in my frame it has a velocity v with component vx, vy, vz, the displacement vx will be vx dt, vy would be vy dt, vz dt. So let's write down the expression here. So this will become, firstly, I will write it down, c squared dt squared minus vx squared plus vy squared plus vz squared dt squared equal to c squared d tau squared. Right? I am writing this expression. Left hand side here is c squared dt squared minus, I am pulling out my dt squared, vx squared plus vy squared plus vz squared. That must equal c squared d tau squared. So from this equation I get c squared dt squared minus v squared dt squared or dt is equal to gamma. Okay. So that's the relation between these two. So now let me write, I write my u mu as dx mu by d tau. D tau does not transform under Lorentz transformation. Dx mu transforms like a 4 vector. So u mu transforms like a 4 vector. This is statement clear. So now let's see what are the components of u mu. U0 which is C dt by theta, which is equal to C gamma. Let me just remind you, gamma is nothing but 1 by square root of 1 by what is U1? U1 is dx 1 by theta, which is dx1 by dt times dt by theta. And what is this? This is just the velocity, v component x dt by theta is gamma. Similarly, U2 is gamma Vfy and U3 is gamma. How would U transform under a Lorentz transformation? Can you tell me what is the answer for transformation of this under a Lorentz transformation? It will be U prime mu will be, what will be the relation between U prime and U? Exactly the same, because it's a vector, 4 vector. So just like in ordinary 3-dimensional expressions, if position vector changes in
union.
Pardon?
It will be union.
Right.
Oh, thank you. So now U0 squared minus U1 squared minus U2 squared minus U3 squared. What should this be? It should be the same in all frames. It should be a Lorentz scale. And let's calculate what that quantity is. This quantity is C squared gamma squared minus gamma squared times Vx squared plus Vy squared plus Vz squared. That is V squared, and when you add these two, you will find the answer. Just V squared minus V squared times gamma squared, which is C squared times 1 minus V squared gamma squared. Notice this transformation property is much simpler than the transformation property I had for velocities. The standard velocity. Let me just remind you what kind of a thing did I have. I had Vx prime equal to Vx minus Ux prime was Ux minus V divided by 1 minus Vux by C squared. And Uy prime had some gamma and so on. But this is a bigger mess. This is a much cleaner situation. Is this statement clear?
Saying this statement, how you got C?
Pardon?
How you got C square?
Okay. From here, I put C squared outside. That is 1 minus V squared C squared. And what is gamma squared? Is 1 by 1 minus V squared by C squared. So these cancel and that cancels. Okay? So how do you think for momentum we define?
Just multiplied by mass.
How should I define? Now, I have a 4 velocity. I should multiply it by a scalar because it has to be the 4 momentum. So I multiply by the standard rest mass times u. So this is nothing but the components are, I have u0 component there, F C gamma times the other components are gamma. P transform. P prime mu will be lambda mu nu Now, let us recall the argument I had presented yesterday regarding conservation of momentum. How simple the entire thing is going to look at if I look at it from four momentum. Consider two particles, A and B. So, P mu A is the forward momentum of particle